Today the topic is virtualization, and I'm going to show you how to install Docker on Windows step by step. I'm Leo and this is my channel Leo Tech Lab. If you don't know it yet, take a look at the introduction video. Let's go. Given that I already made a video about installing Docker on Linux, I thought it would be relevant to do the same for Windows. In this video, it is assumed that you already know what Docker is and how it works, even if only in a basic way. If you don't know Docker yet or want to refresh your knowledge on how it works, you can watch my Docker in Linux video that I mentioned earlier. Links will be in the description. Objectives for this video. First, install a Linux virtual machine on Windows. You can check a link in the description for a video that I already made exactly on this topic. Second, install Docker on the Linux virtual machine. You can also check a link in the description for a video that I already have exactly on this topic. And third, to wrap this all up, run a container that streams video from a USB webcam connected to our virtual machine to validate the pass-through of USB devices to our Docker container. As we already know, a container allows for a virtualized and isolated execution of applications in a much more efficient way than a conventional virtual machine. However, containers are not agnostic to the host operating system they run on, as they rely directly on the core of the host operating system, also known as the kernel. This means that, broadly speaking, we can have two types of Docker images, Linux-based and Windows-based. The most common images are Linux images, perhaps because it was here that Docker was born, or also because it is an open-source operating system, unlike Windows, which is a proprietary and licensed operating system. As such, we'll focus on the more common scenario of Linux containers. For Windows, we basically have two options for running Linux Docker containers. Install Docker Desktop directly on Windows, or manually install a Linux virtual machine and then install the Docker engine inside it. Until recently, I always used Docker Desktop, because it was more convenient and faster to install, in addition to using Microsoft's Hyper-V, a Type 1 hypervisor with excellent performance, or in the case of WSL2, which is Windows subsystem for Linux, a subset of Hyper-V. However, I changed my mind when I needed to connect non-storage USB devices, such as webcams and printers, to my containers. Unfortunately, Hyper-V doesn't allow direct USB pass-through for these types of devices. There are more complicated workarounds that use USB over IP, but with a loss of performance and extra complications, such as having to compile the driver for my devices directly from the source code and manually adding them to the Linux kernel. In short, too complicated for the benefit it brings, in my opinion, which made me rule out this option. As such, I had to make the switch to option 2. Manually install a Linux virtual machine and then install the Docker engine inside it, in order to have access to my USB devices inside the Docker containers in a simpler way. On top of this, the fact that I'm explicitly installing the virtual machine allows me the best of both worlds, knowing how to use containers and knowing how to use virtual machines. With Docker Desktop, I never actually have to deal directly with a virtual machine, which can be seen as a good thing with less work. But actually, I think it turns out to be not that great, because it hides too many details that are actually essential for us to be able to run our containers in a robust and controlled way. But this is just my opinion. The plan for this video is as follows. We'll start by installing VMware Player as our hypervisor and a Linux virtual machine. Access to the virtual machine is done using the terminal with SSH. For more details, check out the video dedicated to this topic in the description. Next, we're going to install the Docker engine inside our Linux virtual machine. For more details, check the video dedicated to this topic in the description. After that, optionally, we'll enable shared folders for our containers. You can look at these steps in more detail in the virtual machine installation video in the description. Finally, we're going to run a container that streams video from a USB webcam to our home network, and we're going to test the consumption of the stream with another computer connected to our home network. Okay, the first step is to install a Linux virtual machine on Windows. And for this step, as I already said, I have a video on how to install Linux VM on Windows. Okay, the link is in the description, just in case you don't know how to install a Linux virtual machine on Windows. But from this point on, it is assumed that you have your Linux VM running on Windows. Okay, mine is over here, and I'm using Ubuntu 24.04 long-term support. Okay, by the way, if you've watched that Linux VM install on Windows video that I said, this virtual machine is now at the exact same state as it was at the end of that video. For the installation of Docker Engine on Linux, I've already made a detailed video of the process. Okay, the link is in the description for that video as well. So this time I'll do the installation a little bit faster and with less explanations. Okay, basically what I'm going to do is I'm going to look for the Docker installation guide on Ubuntu and just follow the steps. So let's do that. Let's search for Ubuntu Docker install. And it's this one over here. OS requirements. Okay, mine is this one. Okay, but it should work fine for most Docker, Ubuntu distributions. So the first one, run the following command to uninstall conflicting packages. Copy. Let's SSH into our virtual machine. Here we go. And now let's copy and paste this line. Enter. Password. So this is just to clean up, I guess, old Docker installations. Okay, it's done. Now, okay, set up Docker's apt repository. So let's add these sources to our apt repository so that he can find the packages to install. Done. Next, install the Docker packages. To install the latest version, run. Okay, let's run this. Copy, paste, enter. It's going to install the Docker binaries. This usually doesn't take that much time. It's done. Okay, now next step, verify that the Docker Engine installation is successful by running the hello world image, or in this case a container based on that image. Let's do this. Copy, paste, enter. Success. Okay, we have successfully executed the container based on that hello world image. Perfect. One more thing though, we are using sudo to execute the Docker command. We want to do this in our own user, so we need to add our user to the Docker group. Next steps, continue to post installation steps. Click here, and over here, manage Docker as an unroot user. Not manage, but yeah, this one. Create the Docker user group. I think Ubuntu already does this, but let's try it. Yep, Docker already exists. Okay, and next add your user to the Docker group. Copy, paste. Okay, my current user, which is Leo, it's now added to the Docker group. So now let's just restart our machine and test if we can correctly use Docker with our own user instead of just root. Let's wait for it to boot back up. Okay, that's it. The machine is back up. So let's SSH into it. Here we go. And let's try and do Docker PS. Okay, perfect. So PS is for listing active running containers. There is none, but if we do Docker PS -A, which is give me all containers running and non-running, we should be able to see the hello world container. And here it is. Okay, created 2 minutes ago, exited 2 minutes ago. Yeah, it was pretty short-lived, that one. So that's it. We already have the Docker engine set up and ready to use. So let's go on to the next step. Okay, so shared folders allow you to share part of your host file system with your virtual machine, so that both systems can have read and write access to those shared folders. This step is completely optional, so you can skip ahead if you're not interested in shared folders, but I recommend that you do it for 2 reasons. Number 1, you can take advantage of shared folders to allow direct access to container files from the Windows host system, which makes it much easier to edit them directly in Windows, in my opinion. And number 2, if you configure your container volumes to point to shared folders, they are automatically backed up from your virtual machine, given that they are being written to your host file system. This way, even if by any reason you lose your virtual machine, you can always restore your containers later, even in the context of another virtual machine. So if you're interested in this step, I recommend the Linux virtual machine installation video on Windows, once more, which explains in detail how to configure the shared folders from the host system to the virtual machine, okay? The link, as you already know, is in the description. Now, for those of you who have already saw that Linux VM installation video on Windows, the state of this virtual machine is exactly the same in terms of shared folders, okay? So we are exactly where we were. If we go ahead over to virtual machine settings, we still have a shared folder named shared, which points to CVMs shared, okay? It's this one over here, CVMs shared. Currently it has the same text file, test.txt, okay, that we used in that video to test the bidirectionality, and it can be accessed also in our virtual machine, in the host directory, in our home directory. Inside here it is, the shared folder, and inside here the same test.txt file, exactly the same contents, okay? So now on to the next step. Now that we have the Docker engine set up, let's try to launch a container that makes use of our webcam, thus ensuring that access to the USB device is confirmed. Given that we don't have a graphical interface on our virtual machine, the idea is to use a video streaming program which uses our webcam to capture video and then outputs it in a format accessible to a browser. Just like we did in the installation video of the Linux VM on Windows, we will use the Ustreamer program for this purpose, but this time inside a container and not directly on our Linux system. A quick note here, if you did my previous tutorial on how to install a Linux VM on Windows, you need to ensure that the Ustreamer application you installed in that tutorial is not running. Otherwise, it will conflict with the Ustreamer application that will run in the Docker container. To do this, simply remove or comment the line that automatically launches it at startup in the cron tab, if you remember correctly, or uninstall the application with sudo apt remove Ustreamer. And that's exactly what we have to do, because actually we do have Ustreamer installed and it can't bind because it is already running in the background, and we can check that by going on our virtual machine IP in the port 8080, and here is our webcam. Okay, so let's stop our Ustreamer from running automatically at boot, shall we? Sudo cron tab -e. So this is the cron file for the root user. And over here we have at reboot launch Ustreamer and attach it to the interface 0000. This is the line we need to comment. Okay. The other line is for the shared folder, so leave it. But the first line we need to comment it. Control X, yes, enter. And now let's reboot our machine and confirm that Ustreamer is not being launched automatically. Sudo shutdown -r now. Okay, let's just wait for the machine to boot, and we'll confirm that Ustreamer is no longer being launched automatically. The machine has boot up, so let's test again. And this time we don't have a stream. Okay, this is good news. Now let's SSH into our virtual machine. Okay, so Ustreamer is no longer running. We can also confirm that with the netstat -a pipe more, and we'll see that the 8080 port, the HTTP alt port, is not being exposed on the interface 0000. Okay, perfect. Now, for those of you who didn't see the Linux VM installation in Windows video, before we start, let's just make sure that the webcam is properly connected to the VM and the USB pass-through is active, okay? So this is the webcam, removable devices, Microdia H2 live camera. This check mark here tells us that the webcam is currently connected to our virtual machine, okay? So it's connected to the Linux virtual machine. And now we can use the command ls USB to list all the USB devices currently connected to our virtual machine. And here is our web camera, Microdia H2 live camera. Bus 3, USB bus 3, device 3. Now we can use the ls USB -t command to see in a tree format these devices, and we can check if they have device drivers loaded. So bus 3, device 3, it's these 4 lines over here, and we have 2 device drivers for UVC video and 2 device drivers for sound and audio. Okay, perfect. So this means that we have device drivers loaded for our webcam, meaning that we can ls the /dev directory and search for video files, video asterisk. Okay, and we have 2 of them. So the video 0 file represents the video stream of the webcam, and the video 1 is the metadata for the video that is currently being played on video 0. Okay, perfect. Everything is okay. We can continue. I usually store all the contents of my containers inside a dedicated folder, and for that I will create the containers folder inside the shared folder, okay? Which means going to host, shared, and inside here I will create the containers folder, okay? And given that I have shared folders enabled, it will show up here also. C VMs shared, here it is, okay? So this folder containers, and this one is exactly the same thing, okay? If you haven't done the optional step of shared folders, or if you just don't want to use shared folders, that's not a problem. The process is exactly the same. It's just not going to be visible to your Windows host. Okay, so the full path to this is /home/leotechlab/host/shared/containers. Okay, moving on. Inside the containers folder, I'm going to create a folder for each container that's running. You can do it differently, of course, but this is just how I usually do it. Okay, so I'm going to create the UStreamer folder, and inside it will be basically all the files related to UStreamer, to the UStreamer container. Now let's go to the container itself. Personally, I prefer to use the Docker Compose system to manage my containers, so that's what I'm going to use here. Okay, and to do that, let's create a file called docker-compose.yaml, and we're going to nano docker compose YAML. Okay, and we're going to fill it with the content that is specified on the page of the UStreamer Docker image that we are going to use. Okay, and that's in the central repository, the Docker Hub. So let's go to Docker Hub. Okay, and let's search for the image of UStreamer. And we have several, but the one we want, it's the first one, the mkuf/UStreamer. It's this one, okay? And over here you have like a README, an overview, some documentation, okay? But it does tell you how to run this image, okay? How to create a container based on this image. So if you want to use command line, do this, but we want to use Docker Compose. So this is the contents that we must copy to our Docker Compose file. And here we go. Okay, so this basically means that I want to create a UStreamer service based on this image, mkuf/UStreamer, the latest version. Here is the port forwarding rule. So all requests coming to port 8080 on my host, and my host here is the Docker Engine host, which is the Linux virtual machine. So all requests arriving to port 8080 on my Linux virtual machine, direct them or forward them to port 8080 on the UStreamer container. Okay, same thing for devices. So basically this is telling us to share the /dev/video0 file from our host and represent it as /dev/video0 file inside the container. So this is how the USB pass-through is achieved here. Okay, and this is how the container is able to access our webcam through this file link. Okay, there's one other thing missing here from this file, actually, is the restart policy. Because I want to have the same behavior I did in the other video, in the Linux VM installation on Windows, which was each time I restart my virtual machine, I want UStreamer to restart automatically. And for that video, we used cron, okay, to launch it automatically on boot. But using Docker, we don't have to, because Docker Engine has something that's called the restart policies. Okay, and we can use those restart policies to specify how we want to restart our containers. And so how do we do this is we add another attribute, restart, and now we specify the restart policy. And in this case, I want to use the restart policy that says, unless explicitly stopped, I want Docker Engine to always resume containers that were running when the virtual machine went down. Okay, so in this case, I'm going to use unless -stopped. So this is telling Docker Engine, unless the container is stopped, explicitly stopped when the virtual machine goes down, I want that container to be spun back up when the virtual machine boots again. And by the way, we can do another thing just for you to see how easy it is to port forward in Docker. Okay, this port here, the second one, is the container port. So this is kind of fixed because the application, the UStreamer application inside the container, is expecting to receive data from port 8080. So this you cannot really touch this. Okay, but this one represents the port that you want to be open and forwarding to port 8080 on the container. So this represents your host port. Okay, so this you can use anything you want as long as it is a valid port, of course. So we can use like 2, 3, 4, 5. So every time a request comes to port 2, 3, 4, 5 of our Linux virtual machine, forward that communication to port 8080 on the UStreamer container. Okay, perfect. Let's test this. Control X, yes, enter. Now all that's left is to launch the container by running the docker compose up -d command. Okay, so docker compose up -d. This makes the Docker engine check if it has the image, the mkuf/UStreamer Docker image in its current local repository, meaning inside the virtual machine. If it doesn't, it will download it from Docker Hub, okay, and then it will create a container based on that image, okay, and according to the configurations present in our Docker compose file, okay. The -d option over here just makes the container run in the background. Okay. Once the container is active, we'll try to access the video stream on our browser, going to our virtual machine IP and port 2345. Okay, remember that we changed the port to 2345. By the way, I don't know if I have that Docker image stored in this Linux virtual machine or not. Okay, if I do, it will just spin up a new container. If not, it will download the image first and then it will spin up the container. Okay. Yeah, I already have the image, so it's just creating and running the container straight. Otherwise, it would say downloading image. Okay. So basically, it created a specific network for our container. Okay, and configured it with our port forwarding rules, and created the container as well for our UStreamer application. And this means that we can do docker ps to list all the active Docker containers, and we will have our container. This is the container ID based on this image, this version. Okay, this is the command that the container is running internally to launch the UStreamer application. It was created 29 seconds ago, and it is forwarding the port 2345 from this interface, meaning it is listening to all interfaces. It is forwarding this port 2345 to port 8080 on our container. Okay, and its name, it's UStreamer-1. Okay, this is a generated name. Okay, meaning that if we do netstat -a pipe more to see our open TCP ports, we will see port 2345 open and waiting for a connection on the 0000 interface. And here it is, 00002345, it's listening. Okay, great. This means that we can go to our browser, input our virtual machine IP address, but in this case, the port is 2345, and we have our UStreamer straight from our Docker container. Excellent. Now there's only one more thing left to do, which is to reboot the VM to ensure that the Docker container is being automatically started by the Docker engine. Okay, so let's do our sudo shutdown reboot now, sudo password, and let's wait a little bit for the virtual machine to reboot. And after that, we'll go straight to our browser and see if we still have the Ustreamer app running on port 2345. Okay, let's check the browser. For port 2345 and success. Let's confirm this inside the VM. Let's SSH into the VM and let's issue a Docker PS to see the Docker running. And it's exactly the same container, okay? It was created 4 minutes ago, but started up 26 seconds ago due to the latest reboot, okay? Still the same port forwarding rule, still the same name. Perfect. Everything is working. This tutorial is done. And that's it. I hope it was useful to you. Please leave your feedback and share your ideas and opinions in the comments. If you want to stay up to date with the latest videos, you can subscribe to the channel and click the like button. Thank you, and I'll see you next time.